Hi, hello everyone, my dear students. So I welcome you to the NEET World. So my name is Ajay and I am your chemistry faculty. Okay. So focusing on the upcoming NEET entrance exam. So here we have came with a very important series of videos, that is important concepts for NEET exam. So as a part of this series, so we are going to cover the topic mole concept and the basic and very important topics from this particular chapter. Okay, so here in this video I am going to cover, these are the topics which I am going to cover in this particular video. Okay, so everyone knows that mole concept is one of the very important topic, and this will be very helpful for the other chapters of chemistry and physics also, right? Okay, so in this particular video we will cover completely about mole concept, and the next methods to calculate number of moles, and the interconversion, and the next numericals based on that, and the next percentage composition and empirical and molecular formula and its relation, and previous year questions related to this particular topic. Okay, let us start our video. Okay, so here what exactly a mole? So what is mole? So when we are going to a market, so usually we will try to buy some vegetables or whatever it is. So let us say we are buying some kg of tomatoes. So in kg of tomatoes, we may approximately we can say there will be some 10 to 12 tomatoes, right? So similarly, when it comes to chemistry, so even we take some small quantity of any chemical substance. Okay, so in that small quantity, we know a lakhs or crores of n number of particles will be there, atoms will be there. We know atoms are very small particles, right? So in order to express that number of particles present in that particular whatever the quantity we are considering, we need this mole is a word will be highly helpful. So for example, if we go for a market or anywhere, so if I say one pair, so what do we mean by one pair here? So one pair means it is of two number. It means if I say one pair of shoes, it will be two shoes. If I say one dozen of apples, it will be 12 apples, right? So if I say one dozen, so it will be something like 12, right? So if I say one dozen eggs, you are saying it as one dozen eggs. If we say it is something like 12 eggs we are considering, right? So similarly, when we are saying one mole, so it can be considered as 6.022 into 10 power 23 particles. If I say one mole eggs, you can consider it as 6.022 into 10 power 23 eggs. So something like that. So mole is a word used to express this many number of particles. Okay, so this particular number which we are writing over here is considered as Avogadro number. So what is the name? So it is considered as Avogadro number, and it is indicated with symbol Na. Okay, so this will be very helpful for us. So you should not be confused with the term mole. I hope it is very clear. Similar to dozen, we have a term called mole to express how many number of particles present in a particular substance, whatever the quantity we are taking. Okay, so this is how we can give. So here I have given the bookish example or definition over here. So you can read this. A mole is defined as amount of substance that contains as many entities as there exactly in C12 carbon. So C12 is a carbon isotope. So if I take 12 grams of that carbon isotope, if I take 12 grams of C12 carbon, and by experimentally measuring by using some like mass spectrometer or like a proper instrument used to measure number of particles present in this particular substance. So it was found to be 6.022 into 10 power 23. If I take 12 grams of carbon, so it contains this many number of carbon atoms or carbon particles in that amount of substance. Okay, so that number is called as what? Avogadro number. Okay, let us move further. So as I explained you, one pair means two shoes. So same story. So if I say one glass of pencil, it means it has 144 pencil. If I say one mole of hydrogen atom, it means you should consider it as it contains 6.022 into 10 power 23 hydrogen atoms. Okay, if I say one mole of hydrogen molecule, so if I say one mole hydrogen H2 molecule, molecule, you can consider it as 6.022 into 10 power 23 H2 molecules. I hope it is clear. Okay, let us move further. Okay, so here, in order to express what is the weight of those particular particles or atoms, we have molar mass. If I say molecular mass or atomic mass, if I say atomic mass, this is the mass of one atom. If I say molecular mass, that is the mass of one molecule. So here we are using another term called molar mass. So molar mass means mass of 1 mole of particles. Just now we have seen now. So 1 mole means what? So we just now we have seen 1 mole means Avogadro number of particles we have seen, right? So the mass of all these 1 mole particles, that is what? 6.022 into 10 power 23 particles are there now. If I say 1 mole carbon, okay, so this will be containing this many number of carbon atoms, okay, carbon atoms, and it will be weighing something around 12 grams, okay. So what is the molar mass of 1 mole of carbon? The molar mass of carbon is 12 grams. It means the mass of 1 mole of particles, atoms or molecules or anything, that will be considered as its molar mass. So the units which we are using is grams, right? So here you can read this definition, the mass of 1 mole of entities. Okay, in 1 mole we know this many number of particles are present, and the mass is expressed in what? Grams. Okay, gram per mole. Okay, so what is the unit for molar mass? Gram per mole. Okay, so now this particular definition, if we observe here, the units used to express molar mass is gram per mole, right? Okay, so the name of this molar mass is also considered or called as gram atomic weight for atoms and gram molecular weight for molecules. Okay, so we can call it as molar mass or gram atomic weight for atoms or gram atomic mass for atoms and gram molecular mass for molecules, or in simple words there is also another name, so it is also called as gram atoms. So you should not get confused when there is this kind of terms if you have seen anywhere. Okay, so we can call it as molar mass or gram atomic mass or gram atomic weight or simply gram atoms. So gram atom means what? So it is the weight of 1 mole of that particular atom. Okay, so let us do some questions how to calculate atomic weight and molecular weight for different compounds. So let us say, so if I say oxygen atom, so in if we consider this oxygen 1 mole of oxygen atom, if I say 1 mole of oxygen atom, then what is its molecular molar mass of this 1 mole of oxygen atoms? So this will be how much? 16 gram per mole. Okay, similarly here it is atom. Now I am taking 1 mole of O2, which means oxygen molecule. This is not an atom, it will be molecule. So we know in the nature oxygen exists in molecular form, not in atomic form, right? So we need to know how to express this molecular form. See how many oxygen atoms are there in one molecule? It contains 2, right? So we should multiply this 2 into its atomic weight, or gram atomic weight. Gram atomic weight, the short form I have written. So here, so this number whatever we are looking at here, so that is called atomicity of this particular atom. So number of atoms is indicated by here at the subscript here. So this number is called atomicity. So let us make a formula for this. Atomicity into gram atomic weight. So here what is the atomicity? Here we have 2, right? So you should take it as 2 into what is the atomic weight for one, gram atomic weight for one, 1 mole of oxygen atoms, it will be 16. Therefore we can write it as 32 gram per mole. Similarly, can you try to find for this 1 mole of O3. So what is the weight in grams? What is the weight of 1 mole of O3? So O3 is nothing but ozone, right? So you can say atomicity is 3. 3 into 16, if you do, you will be getting. So let us do few more questions. So here, so if we observe this, let us do some more questions over here. So let us take C2 H6, let us say. So C2H6 if we take, so what it is called? It is called as ethane, right? So what is the molecular weight of ethane if someone asks you? So how do we do this? So how many carbon atoms are there here? So 2 carbon atoms are there, multiply it with what is the molecule atomic weight of, like gram atomic weight of 1 carbon atom? It is 12. So 12, 2 into 12 I have written, plus, so how many hydrogen atoms are there? 6. For each hydrogen atom, we know it will be 1. Okay, so therefore how much we are getting? 24 plus 6. So we are getting 30 gram per mole. Okay, I hope this is clear. So now, so tell me, so here I have given like C6 H12 O6. Can you find it for this? So how do we do this? So what is the atomicity of carbon over here? 6, right? For 1 carbon atom, it will be 12, right? Then next, how many hydrogen atoms are there? 12 into, for each hydrogen atom it is 1 gram. Okay. Then next, for oxygen, we have 6 oxygen atoms into, it will be how much? 16. So if you solve this, so we will be getting it as 180 gram per mole. I hope this is very clear. Okay. So you can do few more questions and you can tell me in the comments. H2SO4 you can try. So you can try H2SO4. So let me write it little more clear. Okay. So you can do for this and you can also do it for OH. Okay. The next thing is, so here calculation of moles here. So I hope you got some clarity on how to find, like how to define moles, right? Now let us look into how to find number of moles. So now here sometimes they may give the first case. So how do they ask questions on this? Let us see. If weight is given, sometimes what they will give? They will give the weight of a substance. W2 means weight. Weight of a substance. Weight of a substance is given. Substance they may give. And they may ask us to find, calculate number of moles. So this is the first way of asking question. So number of moles can be represented with small n, let us say. Okay. So calculate number of moles. That is what n they are going to ask. Okay. So now, for example, so here let us see one question. So here I am giving you 22 grams of CO2 is given. Express it in number of moles. So this is a basic question they may ask us. Okay. So like this if they ask, so how do we do? So we know if I take 1 mole CO2 if we take, so in 1 mole CO2 how many moles of carbon atoms are there? 1 mole of carbon, because atomicity, it means how many carbon atoms are seen in this particular molecule of carbon dioxide, it will be 1, right? So if I say 1 mole CO2, so here we have 1 carbon, and for 1 mole of carbon it will be 12 plus and 2 oxygen atoms into, for each oxygen atom it is 16, right? So how much we are getting? This is 44 grams. So the weight of 1 mole CO2 is how much? 1 mole CO2 is 44 grams. Now they have given the weight. How much they given? So they have given 22 grams and they are asking about how many moles are there. So they have given this as 22 grams and they are asking us to find number of moles. So just use the unitary method. It means, so you just need to take it like this. So you just multiply like this. So here we are getting, see here 44 becoming 22. It means it is half of this. So here also 1 mole becomes half of that, means half mole, right? So here just use this method from this. So 1 into 22 I am writing, which is equals to, see here in this is what we need to find now. Let us consider it as x. So x into 44 you can take. So here also grams. So it will be 2 times. So x we are getting half mole, right? So this is how you need to express if they give in terms of weight. Okay. So now let us generalize this formula, this type of calculation into a general formula. So number of moles you can calculate. So n equals to given weight by, so you just take whatever the weight given on the numerator and here divided by gram molecular weight. So both are in grams and here it is gram per mole. So if you do this, so gram get cancelled and we are remaining with number of moles. So just substitute over there. So NCO2 will be equals to how much here? CO2 will be how much here? So what is the weight they given? 22 grams. So take it over here. And what is the molecular weight of gram molecular weight of CO2? It is 44 gram per mole. So now we are remaining with half mole. So this is how you need to do. I hope this is clear. So let us do one more model. So this is the first model. They may give us what? They may give us weight and they will ask us to calculate number of moles, right? The next one is they may give us second method. Okay, so number of particles may be given, particles or entities may be given, then calculate number of moles. So how do we do this? So for example, we know in 1 mole of any substance contains how many? 6.022 into 10 power 23 particles, right? So now if they give this particle and asking us to find number of moles, so just do the same unitary method, we will be going to get the answer. So here, if for example here, let us say some 3.011 into 10 power 23 particles are given. So now tell me how many moles it is. So by just looking by the formula, like whatever the theory I have written over here, so this is giving, see, so from here to here it is becoming half, so this will also be becoming half. So we can write the formula as number of moles equals to number of particles. This will be given by them. So just take it as given by like Avogadro number. So this is what Avogadro number, no? So take it as 10 power 23. Okay, so if you do this, we are going to get the answer. Now I will be asking you one question. Find number of CO2 molecules in 22 grams of CO2. So I hope the question is very clear. So I have given 22 grams of CO2. I am asking you to find number of CO2 molecules in this 22 grams. So how do we do this? So the first step is to do is convert this given weight into number of moles, that is what? N. So after converting into N, then multiply this N with the Avogadro number, we are going to get our answer. Okay, so let us see. So first find number of moles. How do we find number of moles? Given weight is how much? 22 grams, and given weight by molecular weight of CO2 is how much? 44 gram per mole. Therefore we are getting it as half mole. How much we are getting? Half mole, no? So in half mole, how many particles will be there? We know if it is 1 mole, if it is 1 mole, Avogadro number of particles are there. 022 into 10 power 23 particles are there. So, but how much answer we got here? Half mole. It means 1 mole means this many. So, half mole means half of this number. So, that is what? Half Na. Simply write half Na, or you can write half into 6.022 into 10 power 23. So, that is nothing but 3.011 into 10 power 23. So, this will be the answer. I hope this model is also clear. So, let us look into one more model. So, now sometimes volume is given, you can write completely, volume of a gas is given, and they may ask us to find number of moles. So these are the three models we may expect basically. Okay, so now here volume of a gas is given and they are asking us to find number of moles of that particular number of moles of gas they are asking us. So how do we do this? Okay, so if we take the basic like law is there here. So what is it? Avogadro's hypothesis, or we can say Avogadro's law. So in order to understand this concept, we need to know what exactly Avogadro's hypothesis or Avogadro's law here. So what he is saying is equal volumes of all gases contains equal or same number of gas particles, or simply say gas molecules or atoms, whatever it is, molecules at constant or identical, at constant temperature and pressure, or identical, sometimes it may be also written as identical temperature and pressure. So whatever the gas you can take at particular temperature and pressure, if we measure how many particles of these gas molecules are there in that particular container, it will be same whether you take hydrogen gas, helium gas, whatever you can take. So at particular temperature and pressure, it always gives same number of gas particles. For example, at STP conditions, it means at STP means you can consider 1 atm pressure and 273 Kelvin, 273.15 Kelvin, or just you can write 0 degrees Celsius. At this particular condition, we will be always having any gas, all gas molecules, like all gas molecules, any gas you can take, molecules occupies, like you can write it as 1 mole of any gas occupies 22.4 liter of volume. So 1 mole of any gas occupies how much volume? That will be 22.4 liter. So that will be fixed. So if you take 22.4 liters at STP condition, it contains how many moles of gas molecules? It will be having 1 mole of gas molecules. Okay. So if I say 1 mole CO2 gas at STP condition. So 1 mole CO2 gas at STP condition means, so you just directly you can write it as how much volume it will be having. It will be having 22.4 liters, or you can say half mole CO2 gas at STP. So how much volume it will be having? So if it is 1 mole, this much volume it is occupied. So if it is half mole, it will be half of this. The volume occupied by this particular amount of substance is how much? half of it 11.2 liters. If it is only 1 by 4 mole, 1 by 4 mole of CO2 gas is taken at STP. So then how much volume it will be occupying? So half of this, how much it is? 5.6 liters. I hope you got how to interlink mole to the volume. Okay, so now instead of saying 1 mole of CO2 gas, I can also give it as how much? 44 grams of CO2 gas at STP. I can also call it as 44 grams instead of 1 mole, right? Because 1 mole of CO2 means how much molar mass it is? 44 grams only, no? So 44 gram per mole is a molar mass for CO2. That's why I can write it like this. So instead of writing half mole, they may also give it as how much they may give? 22 gram of CO2 also they may give. Okay, so here they may mention it as 11 grams of CO2 also they mention. I hope you got how to connect 1 mole to, moles to volume or weight to volume. Okay, so 3 things are covered. So let us make a generalized formula for this one. So number of moles is equals to given volume by 22.4 liter. So given volume must be at what? At STP conditions only. So number of moles is what? So you can take given volume by 22.4 liters. So given volume should be 22. It should be in liters only because in the denominator I have written liters. Okay, so both units should be same. So here, for example, I have given you some 5.6 liter of O2 gas at STP. If I mention like this, so how do we find number of moles? So find 5.6 divided by, since it is mentioned at STP, so what we can do? Just 5.6 liters by 22.4 liter. So we are going to get it how much? 1 by 4 mole. So instead of asking number of moles, if they ask us to find weight of that particular O2 gas, so weight of O2 gas if they ask, so how do we do this? Number of moles, what is the formula for number of moles? Given weight by molecular weight, no? So given weight, so I want weight, so molecular weight into number of moles, N into molecular weight. So what is the N value we got? 1 by 4. What is the molecular weight of O2? That is 32. So it will be 8 grams. So 5.6 liter of O2 can also be expressed as 1 by 4 moles, or it can be also written as 8 grams of O2. I hope this is also very clear. Okay. Then see, so let us generalize or let us interlink from one form to another. So if they given like amount of substance they may give, like given quantity you can take and convert into number of moles, and you can convert that into number of molecules or number of atoms. If in case they may ask for you like how many electrons are there in total for the particular substance, in that particular substance, you can convert that also using the concept. So how do we do? For example, question, let us say 18 grams of H2O is given. Calculate number of electrons in it. Number of electrons in it. So how do we do this? So here take first you have to find number of moles. Then you can find number of moles. They are asking number of electrons. They are asking find number of moles first. Moles of H2O you can find. Then multiply it with number of electrons in one molecule of H2O. That will be giving us the final answer. So what is the formula we have? Given weight by molecular weight. So given weight is 18 grams. And what is the molecular weight for H2O? See, we have 2 hydrogen atoms, 2 into 1 plus 1 oxygen atom, that is what? 16. So totally it is 18 gram per mole. Okay. So you can take it is 18 gram per mole. So how much we are getting? 1 mole we are getting, right? Okay. So how many moles of water we have? 1 mole of water we have. So now in 1 mole water we have 6.022 into 10 power 23 H2O molecules. H2O molecules. In 1 molecule we have how many electrons? How many electrons in 1 molecule? See, in one hydrogen atom we have one electron. Like that, how many hydrogen atoms are there? Two hydrogen atoms. So 2 electrons plus, and from one oxygen atomic number is 8 for oxygen, therefore 8 electrons should be there. So 8. So totally 6.022 into 10 power 24 we can write. So this is how you can calculate if they ask number of electrons or number of protons or number of neutrons or whatever the condition they are given. Okay, I hope this is very clear to you. Okay. Okay, so this is the NEET 18 question, 2018 question. So you can find this is very easy. See, number of oxygen atoms in 4.4 grams of CO2. So how do we find number of oxygen atoms in 4.4 grams of CO2? So what is the first condition? First find number of moles. What is the value of N over here? Then after finding this, convert it into number of particles, multiply with how many carbon atoms are there if they ask for carbon, or how many oxygen atoms are there if they ask for oxygen. Okay, so let us say N equals to, what is the given weight? Given weight is how much? Like, what is the formula? Given weight by molecular weight, gram molecular weight. Okay, so now given weight is 4.4 and gram molecular weight is 44 gram per mole. So from these we have got this as 0.1 mole. Okay, how many moles of CO2 is there? 0.1 mole CO2 is there. So in 1 mole CO2 we have 6.022 into 10 power 23 CO2 molecules are there. Okay, CO2 molecules are there. So here how much they have given? This is given as 0.1 mole only now. So it means this is divided by 10. This should be also divided by 10. 6.022 into 10 power 22 CO2 molecules are there. CO2 molecules are there. So here they are asking about, they are not asking about CO2, but they are asking about oxygen atoms. So in one molecule of CO2, how many oxygen atoms are there? So here there are 2 oxygen atoms. That is what I told you, atomicity, right? So number of atoms. What is the formula of number of atoms? Just now I told you, atomicity. Atomicity means how many atoms, that particular atoms are there. That is what the atomicity here. So into number of molecules or number of moles into Avogadro number, that is what Na we can say. So this is the general formula you can use here. So what is the atomicity for carbon? So for like oxygen, it is 2, because they are asking about oxygen only. If they ask for carbon, it should be 1. So it is for if they are asking for carbon, it should be 1, but they are asking about oxygen, then you can write it as 2 into how many moles we got? 0.1 mole we got into Avogadro number, you can write 0.22 into 10 power 23. Therefore we are getting this as how much we are getting? 12.044 into 10 power 22 we may get. Okay, so this is how you can do. So choose the option here. So that is 22 I have written. So 1.2 if I adjust, so we are going to get the first option. I hope this is very clear. I have given complete basic idea on this type of questions. Okay, then next, which are the following contains contains atoms equal to those in 12 grams of magnesium. So in 12 grams of magnesium, how many atoms are there? First we need to know them. So here first the basic thing is you need to find number of moles. That will give you clarity here. So how many moles of magnesium atom, like how many moles of magnesium is present in 12 grams? So given weight is 12, just divided by its atomic weight. See, it is given as 24. So this is nothing but half mole only, right? So we know 1 mole of any substance we consider, it contains Avogadro number of particles, right? So now here it is given as half mole. It means half of the Avogadro number of atoms will be there, right? So now here it is given as 12 grams of carbon. It means 12 by 12, that will be 1 mole. So this is not the one, because it should be half mole only. So if we consider, so option 1 is incorrect. Option 2 if we go, so given number of moles of N2 you can calculate So they given it as 7 grams divided by this one. So how much it is? 7 grams. For nitrogen, we know atomic number is how much? For nitrogen, atomic number is 7. So take it as double. So 14 plus 14. So it will be 28. So take it as 28. So this will be 1 by 4. Okay. So similarly, if we consider for C, option C, see what they are asking, atoms contains atoms equal to those in. So here it contains half of this. Okay. So here half 1 by 4 into. So in 1 mole it is like Na number. And what is the atomicity here? They have mentioned 2. So multiply with 2. So 4, 2, we are getting 2. So it is half Na. So I hope both answers are same. So it means option 2 may be correct. Let us look into option 3 also, C also. So number of moles is how much they given? So weight is 32 and molecular weight of O2 also 32. So it means it is 1 mole. Okay, in 1 mole we have like 2 into Na number of oxygen atoms. Why it is like that? Atomicity is 2 and the weight, how much quantity we got? 1 mole we got. So 2 into Na number of oxygen atoms. Therefore we are getting it as 2 Na, but it should be half Na. So therefore only option B is correct. So you can go for option B. Okay. So now here 180 grams I have given. Which are the following represents 180 grams of water correctly. So just what we need to do, take this, given weight is given, convert into number of moles and you can match over here, you will be getting the answer. So you can tell me the answer for this particular question in the comment section. Very easy. Okay. Okay. So now I just want to interlink all these once again. I just want to conclude this topic, whatever we discussed over here. Okay. So using this, see here, so this is for your reference. I just want to conclude over here and you can take a screenshot of those particular things. Okay. So whatever they are asking, just take the central thing as number of moles. So number of moles you can consider number of moles. Now, how do we consider if the weight is given? How do we convert this weight into number of moles? So just by dividing with molecular weight, right? Gram molecular weight. Okay. Now, if number of moles are given and they are asking us to find what is the amount of substance, so just multiply this with gram molecular weight. If they are given weight, just divide it with gram molecular weight, we'll get number of moles. If they are giving us number of moles, then multiply with gram molecular weight, we'll get amount of substance, that is what? Weight in grams. Okay. Now see, number of moles are given. Now they are asking us to find volume of gas. Volume of gas at STP only they are asking. So if they are asking at STP, we know 1 mole contains like volume how much? 22.4 liters. So just multiply with number of moles into 22.4 liter will give us what is the volume of that particular gas. Okay. Now if the volume is given and they are asking us to find a number of moles, just divide the same thing with 22.4 liters. I hope this is also clear. Now if they are asking about number of particles, number of like entities, I am writing entities. Okay. So if they give number of moles and they are asking us to find number of particles or entities are like atoms, molecule of a particular gas or whatever the substance they are giving. So just multiply this with Avogadro number, that is what? 6.022 into 10 power 23. Okay. If they are given with this, provided with this number of entities, just divide this with Avogadro number, we are going to get number of moles. So this is how you can interlink all these three things. Okay. I hope it is very clear. Okay. Now so you just apply this concept over here, you will get more clarity. Okay, then next thing is, see here in the volume term, I always mention at STP condition only. If they are asking at other than STP, what we have to consider? Now convert that volume into the number of like volume at STP. Like use this formula from ideal gas equation. We have now PV equals to nRT. From this, you can consider P1 V1 by T1 equals to P2 V2 by T2. So these conditions you can consider at any temperature, whatever they mentioned. Okay, you can consider T1. Okay, this you can consider it at STP, whatever the pressure temperature mentioned, it should be STP. Then you can find volume at STP and you can interlink with the other conditions. If they mention anything other than STP condition, you have to do. If they mention particularly STP, you can directly take this relation. I hope this is very clear. Let us move further. Okay, now highest number of helium atoms is in. So now tell me, in which of these given options highest number of helium atoms are there? See, they have given 2.27 liter of helium at STP. So here it should be, we know 22.7 liter means 1 mole it can be considered. Now they have mentioned 2.27, it means around 0.1 mole. It means how many helium atoms are there? 0.1 into Na, right? So here in the second option, they directly mention 4 mole. It means 4 into Na number. It means Avogadro number of helium atoms are there. So here it is 4 units. It means this is when it is mentioned in unified mass unit, AMU units are U. So it just for per one molecule, like one atom or one molecule or one particle, they have given weight. So here by looking at this, so we can say that 4 moles contain 4 into Na. So that is the largest quantity. They are asking about maximum. So option 2 is a correct option. Okay. So now you can do this, like calculate number of moles of carbon atoms in 90 grams. So this is very easy question. So how do we do this? Number of carbon atoms, like see, first of all find how many moles are there. How many moles are there in the given substance? So it is very easy. So given substance is 90 grams. So what is the molecular weight of glucose? We already did initially. That is how much? 180 we have already calculated at the starting of the class. This will be half mole, right? So I am asking about carbon atoms only, not completely about glucose. For glucose you can say it is half mole, right? So I am asking about carbon. In this half mole of glucose, how many carbon atoms are there? What is the formula of glucose? C6H12O6, right? So you should multiply with the atomicity of that carbon. So 6 you should take here. So it will be 3 moles of carbon atoms. Nc will be 3 moles. Similarly, you can tell me what is the answer for hydrogen and also for oxygen in the comment box. Okay. Okay. So percentage composition. So here in the percentage composition, there are 2 ways to like explain this. Okay. So these are very important, and this is previously asked JEE mains were asked from this topic. So I will explain same example taking here. Okay. So if they ask by mass, for example, let us say a question we are considering. So what is the, like, let me take, what is the weight percentage of carbon in methane? If they mention like this, how do we do? Methane formula is CH4, no? So you can directly take so weight percentage weight of carbon in this. So we know how do we calculate if something like we ask for percentage of particular substance means, see, if I ask what is the percentage of marks, mathematics marks in total marks. So how do we do? Marks obtained in mathematics by total marks into 100. So here also if I ask for carbon, so here you take weight of carbon by total weight into 100. So what is the weight of carbon in this methane? It will be 12 grams, right? So now what is the total weight? It should be, for carbon it is 12, and for 4 hydrogens 4 into 1, so we are getting it is 16. So it should be 16 into percentage, so you can take 100. So how much we are getting? 3 by 4 into 100, so we are getting 3 into 25, so we are getting 75% of carbon is present. By weight if they ask, you have to, by mass or by weight if they ask, you have to say percentage of carbon as 75. Now if I ask for hydrogen, how do we do for hydrogen? So weight of, percentage weight of hydrogen, directly you can take 100 minus 75, you will be getting 25 is the answer. Or else you can do it like, how much weight is for each hydrogen? 4 into 1 divided by total weight is 16 and multiply with 100, therefore you are getting it as 25%. So this is how you have to do if they ask for percentage by weight. Now here for the same question I am asking you to calculate by a mole. Percentage, calculate percentage of carbon by mole in methane. If they ask like this, how do we do this? Percentage by mole. See, in 1 mole CH4, how many moles of carbon atoms are there? Like how many moles? 1 carbon, 1 mole of carbon, and 4 mole of hydrogen are there. So total how many moles now? That will be total 5 moles, right? Total 5 moles. Now if I ask for percentage of carbon by mole, so total moles are how many? 5. How many moles of carbon? 1 into 100. So you are getting 20%. If I ask for hydrogen, how do we do this? So total moles are 5. How many moles of hydrogens are there? 4 into 100. So this will be 80%. So this is how you need to do. I hope this is clear. Percentage composition also. Okay. The next thing is, okay, so empirical formula and molecular formula. See, here empirical formula represent simplest whole number ratio of various elements present in a particular molecule, like in a molecule or a compound. Okay, so whereas molecular formula represent exactly how many number of like elements are present in that particular molecular formula, particular compound. For example, let us say C6H12O6 is a molecular formula for molecular, MF means molecular formula for glucose, right? Okay, whereas CH3COOH, this is for acetic acid, right? Acetic acid molecular formula. This is for glucose, this is for acetic acid. So this is how we can write molecular formulas. These both are what? Molecular formula. Now what is the empirical formula? What I told you, empirical formula is simplest whole number ratio. Like, see how much whole numbers we have here. P, I can take the simplest possible whole number as 6121. It means C1H2O1. It means CH2O. Directly I can write it as CH2O here. And here also if you see how many carbon atoms are there? 2. How many hydrogens? 4. How many oxygens? 2. So here also I can write it as simplest number as CH2O. So these are the simplest whole number ratio, simplest whole number ratio of various elements of this molecule. Here also for of this compound, whatever we are writing over here. Okay, so now these are called as like empirical formulas of this particular compound. Okay, so you should remember that empirical formula may be same for different compounds, but molecular formula will be unique. Okay, see here empirical formula is same for acetic acid and glucose, but their molecular formulas are different. Okay, I hope this is clear. Now how do we relate empirical formula and molecular formula? See here C6H12O6, this is a molecular formula, right? This is a molecular formula, right? So now this molecular formula I am just making it as CH2O multiplied with like 6 here. So just see, this is the empirical formula we got over here, empirical formula, the bracket, and here I am writing it as 6. So molecular formula equals to empirical formula into some number, integer number we may get. Okay, so here I am just making it as a generalized formula. Molecular formula equals to n times of empirical formula. So where n equals to 1, 2, 3, 4, so on, you can consider. So this is how we got the formula over here. Okay. So this is the last question based on the empirical formula and molecular formula. See, a compound X is given. See, this is the last year PYQ question. Okay. So here a compound X is given, which is made up of A, B, C. Okay. In this, it contains 20% of A, like 32% of A, and 20% of B, and the remaining here it is 52. It means 48% of C is present. Okay, by weight. Okay, this is the total mass percentage. Now, what is the percentage of A in the total? Like, see here, 32. I mean, okay, let me take. Okay. So here we can say, yeah. So this is the weight of A. So I just taking it as 32, 32% of A. So weight of A is how much? Weight of A is 32 gram. See, percentage means what? Total weight is, this total sum is 100 now. So in 100 grams, what is the weight of A? Here it is 32. So 32 is the weight of A. So now number of moles of A is how much? Na equals to weight of A is how much? 32. And what is the molecule atomic weight of that A? 64. So how much we are getting? Half. Similarly, for B, we are getting it as 20 grams by its molecular atomic weight is 40. So it will be 1 by 2. Similarly, if I do for C, NC will be, so this is 48 grams. Then its molecular weight is how much? Atomic weight is how much? 32 gram per mole. So finally, we are getting it as 3 by 2. So it means what is the mole ratio? A 1 by 2, B 1 by 2, C 3 by 2. So now you can just take the simplest whole number ratio, B1, C3. So like this, we have only one option, that is option number 3. So this is how you have to solve the questions. Okay. I hope the session is very helpful to you, and you can practice few more questions, and if you have any doubts, you can ask me in the comment section, or we can do in the next upcoming video. Thank you, one and all.